Do you know your index laws? Wasteman. Well, let's address this question. It's a very interesting one. Would you know how to solve it? It says, find the non-zero value of x, for which 16 to the power of x raised to the power of x is 1 over 2 to the power of 3x. Okay. So, with something like this, the key is in how we're phrasing the question. 16 to the power, 2 to the power. We're thinking about powers of numbers. Now, one thing I know here is that 16 is a power of 2 and 4, and 2, well, that's just a power of 2. So if you can rewrite all of this as powers of 2, then we can just equate them. We can equate the powers. Okay. How do we do that? Big pause. So, 16 raised to the power of x raised to another power of x. When we take a number raised to the power, or raised to a power, and we raise it to another power within a bracket, we multiply the powers. Okay? So this is 16 to the power of x times x, which, where's my rubber? So this is 16 to the power of x times x. Now x times x is x squared equals. So before we change any bases, I would like to just simplify things a little bit. This is 1 over. What index rule allows you to do 1 over, or tells you to do 1 over a number? It's reciprocals. Which power reciprocates numbers? Well, this is negative powers. So you could bring this up by making it negative. Okay, so you bring up that denominator, we just make it negative. So the way I remember this is, you guys should know me by now, I say flipping like reciprocals. Flipping like reciprocals, shout out J. Cole. Okay, teaching the youths maths. Okay, so remember that negative power does not make the base number negative. It reciprocates the number. It means do 1 over whatever you're on about. Now we can change this so that it's all base 2. Now 16 is 2 to the power 4. So it's 2 to the power 4. Keep it in a bracket. X squared is 2 to the power of minus 3x. Now applying the same rule here to what we did here, we multiply the powers. So this is 2 to the power of 4x squared equals 2 to the power of minus 3x. 2 to the power of something is the same as 2 to the power of something. The only way that's true is if the powers are the same. It's not possible for 2 cubed to equal 2 to the power of minus 2, is it? All right. So for base 2's to be the same, the powers must be the same. So we have 4x squared equals minus 3x. And we need to solve that. Okay. How do we solve this? Nice and easy. We take the negative side and we bring it over to the positive x squared. So we bring everything to one side, make it equal to 0. Okay. Now, if you're at A levels or anything higher than GCSE, you would know that you can just divide by x because it's a solution we're not interested in. But for my GCSE students, we should just be as thorough as possible to make sure we don't make silly mistakes. So we can take that minus 3x over to the right side, left side, sorry. So a negative on the right side, on the left, on the left side would be positive. Okay, then we're going to factorize out x. There is a common term x. And then we're going to say x times what is 4x squared, that would be 4x. Plus x times what is 3x is 3. Now you have two things multiplying to give you 0. So one of them has to be 0, or both. So either x is 0, or 4x plus 3 is 0. However, x cannot equal 0 because I said non-zero value of x. So here we're going to solve for x. We're going to subtract 3 from both sides. So we get 4x is minus 3. Then we're going to divide by 4 on both sides. X is minus 3/4. And there's our solution. So guys, a very interesting question. Not as tough as the last GCSE question I did when it came to completing the square, but still, it's important you guys are exposed to as many questions as possible. So guys, like this video if you learned something new today, or if it's a question you haven't seen before, subscribe for more maths content. And if you're interested in my GCSE courses, feel free to check out the link in my description. And feel free to join the Lung Gang Reddit page if you want to submit your own questions for a chance to appear on my YouTube and TikTok. Nice.